Alright, so this is question 6. Okay, so what's given to us is that A, B, C, and D is a parallelogram, so there's a parallelogram on the far side, and EBCF is also a parallelogram. So what I did first was I said that line BC is congruent to line EF, because that's the definition of a parallelogram, and that line BC is equivalent to line AD, because that is, again, the definition of a parallelogram. And that made me prove that AD is equivalent to EF, because they both share line BC, which proves that they are congruent. And next I said that BC was parallel to EF, because again, that's the definition of parallelogram, and that BC is parallel to line AD, because that's the definition of parallelogram. And again, using the same method as I did before, line AD is equivalent to, or is parallel to line EF, because they share line BC. And this proves that AEFD is a parallelogram. And to prove that this angle and this angle are the same, we had to prove that it was a parallelogram, because then because opposite angles of a parallelogram are congruent. So since this is a parallelogram, these two angles are congruent.
We're told to prove that ABCD is a kite. So we are given that BC is congruent to AD and that AC bisects angle BCD. So we know through the reflexive property that line AC is congruent to line AC. So this can form two triangles of ABC and ADC. So now we know that angles 1 and angles 2 are congruent because they are bisected at angle BCD by angle or line AC. So now we can prove that the two triangles are congruent through side angle side, because we have the first side is AC, your angle is either angle 1 or angle 2, and you have line BC and line CD. Now we know that the lines AB and AD are congruent through the corresponding parts of congruent triangles are congruent, because you know that the triangles are now congruent. And so ABCD is a kite because you have two sets of adjacent sides.
Prove the quadrilateral ABCD is a parallelogram. So first, we can see that BCEF is a rectangle, and that's given to us. And then, because of this, line CE and BF are congruent because opposite sides of a rectangle are congruent. And then angle CED is a right angle because it's 90 degrees, and that's the definition of a right angle. And then angle BFA is a right angle because it is also 90 degrees, which is again the definition of a right angle. And because angle BFA and angle CED are both right angles, this means they are congruent. And then it's given to us the line ED is congruent to line FA. And this makes triangle CED congruent to triangle BFA by the side angle side postulate. And because of this, line CD is congruent to line BA because congruent parts of congruent triangles are congruent. And angle CDE and angle BFA are also congruent because congruent parts of congruent triangles are congruent. And then because angle CDE and angle BFA are congruent, line CD is parallel to line BA. And this makes quadrilateral ABCD a parallelogram because of the definition of a parallelogram, and lines CD and BA are congruent and parallel.
So I had number 4, and given that quadrilateral ABCD is a rectangle and M is the midpoint of CA, you're supposed to prove that BM is congruent to MA. Sorry, so I already said that ABCD is a rectangle, and that was given. BMD equals CMA, which is the definition of a rectangle. The diagonals are congruent, so that's BMD and that's CMA. The diagonals are congruent. And then CB equals DA. Definition of a rectangle, opposite sides are congruent. So CB equals DA. And then CB is parallel to DA, which is also the definition of a rectangle because opposite sides are parallel. And then angle BCM and angle DAM are equal to each other because alternate interior angles. And then CM is equal to MA because the definition of a midpoint. Both sides of the line are going to be congruent. And then triangle CMB and triangle DMA are going to be congruent through side angle side. And then to prove that BM is congruent to MA, it's just congruent parts of congruent triangles are congruent because the triangles are both congruent and they share sides. So there, BM equals MA.